Hello there. I made this recently, and there's actually other random stuff here, completely unrelated. And I thought I would go over the code. It's it's almost like two different projects that need to be separated. Let's see. I've also got obviously this zombie sprite moving, jump with gravity, collision detection, getting blocked. Actually, the zombie will block as well. Let's make sure about that. I think the zombie blocks. No, not right now. And you can see the cursor is this little gauntlet thing, and right now I'm doing a click drag. Um, yeah, with lines there. So some various features, and then there's this thing. This is actually just rendering onto a quad. It's using this thing called ray marching, and anyway, we'll get into it. It's also what do you call it? Writing the images out so that I can render a video. And the reason I'm doing this video now is that I'm about to add a frame buffer. So this is not a part of my official tutorials, but it's kind of a preview of stuff coming in the future, both from the ray marching standpoint and also kind of like game stuff. I've got collision detection stuff going on. Anyway, so yeah, it's a bit of a preview. And the reason I'm doing it now, like I started to say, is that I'm about to introduce frame buffers. It gets a little more complicated. So thought I'd just do kind of overview of code, just for fun. It's not really a serious video. I got a new mic on this headset, so hopefully that's better. Anyway, so let's go through this code a bit. Yeah. All right. I'm not going to go into like crazy detail on anything. But this is cross-platform, this project. Most of this code is based on my OpenGL series, and you can find that in other videos on my channel. There's also a link to the GitHub in the description. It's not going to be linked to this exact code, though. Okay, so, right. Well, yeah, it is cross-platform, so if not Apple, so that means if it's Windows or Linux, we use this GLAD library that it loads in pointers to the OpenGL functions. Standard C stuff there. It's a C program, main.c. We load the GLFW library. We've got, so the STB image library has this this is just what you do. And in previous, let me make this bigger for people. Okay. Previously I didn't have the writing part here, but I'm using writing images. So yeah, I've got a separate shader just in a header file. Well, it's not a shader. It's the thing that compiles the shaders, and there's videos on that in my series. Now this is, I guess, bad practice, but you know, if it does the job fine for me. If I were writing a library that other people are going to use, then maybe I would check out best practices. I guess because I'm using doing these tutorials, maybe I should look up more, but I mean, it gets the job done for me for now. Yeah, anyway. These are just options, these two lines, basically, full screen, true or false, writing, true or false, meaning writing the images. Basically, it writes the images out so that I can generate video from it. And I'll just show you, let's see, for rendering here, we've got rendering. This is a command I use. It's using a tool called ffmpeg. And the 60 here is the frame rate. It's in two places. Yeah, it's sort of from the internet. I'm doing .jpeg files, so that's why it looks like that. Anyway, yeah, getting back to this, I guess I'll make this full screen as well. All right, what's next? All right, screen width and screen height. These are not being used because I'm using full screen, but if I weren't doing full screen, these would get used to set the height, width and height in pixels. We've got mode and window. These are window for creating the window. Other videos I've done on that already. Frame data. So this one is actually basically you have like I forget exactly what it's called, primary frame or the main frame buffer. There's only one frame buffer being used in this program because I haven't made another one. I mean, any OpenGL program that renders to the window, it's going to have that main frame buffer. And but in order to write to an image, I guess I can't write directly from that main frame buffer. I need to pop it in somewhere first. Kind of makes sense. And so, yeah, I wonder if there's a way to skip that step. But that's not the bottleneck. When I'm writing data, the bottleneck is my write speed on my hard drives. So yeah, that's going to be the bottleneck for this kind of thing. All right, so unsigned char frame data. So this is just your RGB values for the thing, but we've got alpha as well. So that's 4 values there. So it's 4 channels. That's basically just kind of the images that I'm generating. And I just did the math here so that this doesn't seem like a magic number. It's based on HD 1920 by 1080, which is what my screen is. If I were using a different screen, I would need to change this up. And like I said, now next I'm going to add my own frame buffer so that I can generate the images without actually having it up on the screen. Right now it actually needs to be up on the screen for me to do that, since it's using the main frame buffer there. So anyway, yeah, total prints this batch. Well, that's how many images I've printed. We've got setting up a VAO. We'll get into that later. Get texture handle. I've talked about in previous videos, but we'll talk about again. Same here. Oh, okay. Just declaring the VAO. Vertex array object. I mean, this is mainly going to be about OpenGL. So if you're new to OpenGL, I suggest checking out my tutorial. I'm not going to explain in crazy detail everything. These 4 functions, all of this is just related to user input, keys, scrolling, although I'm not using scrolling. It's for the mouse wheel. Is that just the mouse wheel? I think so. And mouse callback, mouse button callback. Yeah, we'll see that later. Last X, last Y, this is not well named. It should be refactored, but it's referring to the most recent positions, basically the current positions of the mouse as an X and Y value. We've got similar stuff for the most recent click and the most recent release of the mouse we're going to be using. First mouse equals true. I'm not sure I'm even using this right now. Let's see here. Yes, because this is here, but I think it's not used for anything. But I just kind of leave it there because it might be important. I don't know. Don't know if it's useful. Is drawing selection box bool. Right. You know what? I'm gonna just hold on. Draw window shader. We'll get into what this is. Gonna get rid of this for a second, and so this is Again, it's like 2 separate projects going on here, kind of doing game kind of stuff. This art, by the way, is from OpenGame. Is it OpenGame art? I'll put a link in the description. It's got a bunch of stuff. And maybe I should even attribute the artists. If so, I'll put that in the description as well. Yeah, there's one of my backgrounds. I had this was a bottom. I can't go down here. It was, wasn't able to go down there. And we've got collision detection and handling collisions a bit there as well. So anyway, just wanted to show you. I forget what I wanted to show you, but I think I showed it to you. Let's go back. Right, is drawing selection box pool. So, I'll do it again. It's just this selection. So I wasn't sure what kind of game I wanted to make. I was thinking like a sort of tower defense where you literally have a tower and enemies come, and a bit of RTS elements. You can select units and move them around. So I wasn't sure if I should have my own player that I can move around or if I should have units that I select. So I thought, well, I'll just kind of prepare for both and later I can decide. I can just not render the player, make a separate version and remove the player's code if I want to, etc., etc. So yeah, so I made this kind of selection box thing. So when you're clicking, it does that. So we have a Boolean related to that. That's what this is. We'll see it again later, obviously. This is related to time, last frame, delta time. Delta time is like if you have a steady frame rate, it's going to be generally the same number-ish. If it's the difference. It's the amount of time elapsed from right now when it gets calculated to minus the time of the last frame. I don't think it's even really been used, but it's just something you have. It gets calculated. It does get used for gravity. Yeah, that makes sense actually. So you use delta time in calculations sometimes because you want this to be sort of frame rate independent. Being frame rate independent is sort of important because you wouldn't want the game to go twice as fast if it's on if a guy or girl has a faster system and you've got say 60 frames a second or even more. It could make the game run really fast. So delta time is kind of important for that. So width and height, screen width and screen height floats, okay, because what we had up here, these are ints, right? We pass these to glfw, and basically, sometimes we need them as floats. So I just did that rather than casting them all the time. Also, just wanted to quickly mention a little tangential thing. I'm working on maybe switching to SDL, just doing a whole other version of the tutorial series using SDL. It's mainly related to just audio stuff. Anyway, thought I'd mention that. Okay, so we've got color. I'm not even using this now, but yeah, we'll see it. It's just color. Rectangle can take a color. Again, that's not being used. Actually, GLFW, I found out, has a rectangle type or class, struct, whatever you want to call this. Not class, I guess, but it has a rectangle type built in. But anyway, I did my own. So let's see. We've got bullets. You saw the bullets. I was shooting them. They have X, Y, and distance shot. They have bullet switch. So yeah, before I even click the mouse, right now it's the mouse click that's shooting the bullets. So before I even click it, it doesn't need to do that code. So it gets switched on at some point. Blocks. So blocks are rectangles that have collision, that are important for collisions. So yeah, anything where the collision detection needs to happen. Right now it's only rectangles where that's being done. Yeah, they have colors as well, not being used. Anyway, I made a little like 2D platformer prototype, and that's where I was using colors for the blocks. So you might see that in coming weeks or months, possibly. Num zombies, there's just one right now, but anyway. So we've got the zombie type, and by the way, anybody watching, correct how I speak, because I'm mainly self-taught. Feel free to correct how I speak and, criticize my code in the comments. More than welcome. So zombie int direction, I'm not using this really yet, but you know, later the zombie should be able to go in different directions, and the sprite would change to reflect that. It has a rect. Okay. This should maybe be inside the struct, I guess. I don't know. Different ways to do that. Check collision, we're going to see that later. It takes pointers to rectangles and checks if there's a collision or not. And okay, so this is one of the shader programs. There's a bunch of shader programs in here we're going to see, but this one is being used in the drawRect function, so I declared it here as a global. drawRect, yeah, it takes a rectangle and a shader. Yeah. Draw window shader. We'll get into what that is, but I use this term window shader. There's probably something better, but these crazy graphics that show up right here. You know, it's just a quad being rendered, so it's two triangles over the entire window, and basically, yeah, so there's going to be a bunch of variations of this, but it's kind of a common thing with like ray tracing, ray marching, etc. You just, if you're going to do ray tracing or ray marching, you render a quad and you do your stuff in that quad. So it's just two triangles. This is, you know, in OpenGL, you're seeing two triangles here. That's it. It's being rendered on a rectangle, a quad. And yeah, the magic happens in the fragment shader. All right, that's actually going to be part 2. I'll go into the fragment shader for you. Anyway, where were we? We haven't gotten there yet. Draw window. So I just called it a window shader. I didn't know what to call it. I started dividing up my shaders in different types. I mean, yeah, I should separate the project out. That will happen eventually. Upward velocity, upward position. Let's see here. Yeah, it's what it sounds like. Can jump bool. So once the player has already jumped, this switches to false, right? So that they can't keep jumping forever. Yeah. Downward velocity, we're going to need that for the gravity so they fall back to the earth. Mouse adjustment. Okay, so this is simply that, it really is that I'm sort of rolling my own cursor here. Yeah, I can click. And this gauntlet cursor here, where it was clicking didn't line up. It's lined up pretty well right now. Like that red little square rectangle thing is kind of where it should be. It wasn't at first because, yeah, it just wasn't lined up properly. So I made some adjustments and I called it these variables here. Line vertices we'll get to. It's the lines actually, yeah, we'll get to it. They get rendered as lines, not quads. Yeah, the lines get rendered as lines, but I should switch them to quads. Anyway, we'll see that later. Num bullets. Okay, we've got bullets. So this is, I think of this as an array. Obviously, it's a pointer, but I think of it as an array of bullets. Yeah, same with blocks, because these are getting, actually the bullets are getting dynamically created, right? And the blocks are necessary for the collision, because the bullets, yeah, I'm going to be doing, let's see, actually I don't think I'm really doing this much yet. I don't know, we'll see. All right. Or I'm not really using it that much yet. I guess I am. I don't know. Okay, this is all Windows stuff, and I've made videos on this before, so I'm not really going to do it here now. I'm not gonna, anyway, this is basically just from the GLFW docs. It makes the window. Okie dokie. This is loading in the glad function pointers if Windows or Linux. So you have if and def there. So if not defined is what that means. And this is preprocessor stuff, so it determines whether the code gets compiled. Determines whether the code gets compiled or not. Okay, end Windows setup. GLFW, so these are communicating to GLFW like which functions I'm using for all this input output stuff. Just telling it, hey, you'll see these functions later. They're at the bottom. Setup VAO, we'll see that later. It's setting up the VAO, the vertex array object. We have two of them in this program. One is for quads and one is for lines, which is called the line VAO, so it's not here. And previously I only had one VAO, so previously I was just binding it once right here, not in the while loop, and then that was it. It stayed as this VAO for the whole project, but now I have the line VAO, so yeah. Textured quad shader. So let me think here. So, okay, we've got all these shaders, and if you've watched my previous videos, this is what I do. Sorry if I bumped the mic there. So yeah, building shaders. This is a handle. These are handles. This one was declared up above because it gets used in that function drawRect. So the ones are being declared here. And so these are unsigned ints, and they act as handles for the shader programs. Yeah, so I've done videos about that before, done videos about this, although I need to make a better video about it, because in that video I did, it was kind of like this video, I talked about the whole project, which is not ideal, actually. But let's see, get texture handle is what it sounds like. These are also, again, like handles, just like with the shaders. So a handle, think of a door handle, you just grab onto it. It gets assigned an integer that through the program it acts as a little identifier for it. Kind of, in a way, under the covers, because I'm dealing with this variable name, right? And sort of GLFW or OpenGL is kind of using these ints in the background, under the covers, under the hood, where I don't really have to think about that. So this line is for transparency. So transparency of the sprites and textures and stuff like that. Not sure why this is declared here. I thought this was declared way above. What's going on? Window height. Up here it's screen width and screen height. Right. So I'm probably doing some really bad practice here. I have to investigate if I can get rid of that or what, because it feels like I have two sets of variables for the same thing, basically. I mean, I already have the int and float versions that I talked about above, but this is specifically for int. Feels like a duplicate, kind of. All right, we are declaring some rectangles. You saw the type def above, and I'm not sure if R5 is getting used. So yeah, I could maybe name these differently, but it doesn't really matter at this point. The program is pretty small. R1 is the player, R2 is the monster, R3 is the cursor. I think that the tower gets just sort of placed in the center manually. I forget exactly. R5 might be the tower. Not sure. I don't think so, because the tower's in the middle, and that doesn't look like it's in the middle. Okay, num blocks. Again, that was the blocks are for the collision detection stuff. So, player a monster maybe doesn't now. I don't know. A little bit Some of this is a little half-baked because I was working on making sort of so that when I would make new ones of this, it would all be a little bit easier to make. This is sort of feels a little hard-coded. I'd like to make it a little simpler to make. I don't know if this is really being used so much. Yeah, it's filling in the blocks. So we have basically I think of it as an array of blocks. It's a pointer, though. And it's getting resized here. And so this is, yeah. I think this could just be a malloc. Except that, was it malloc? Let's see. How many times am I using malloc? Not at all. Right. I forget exactly why. It's like that instead of malloc. I'm too lazy to think about it right now. But malloc and realloc, they're a little different what you put inside here. So it's allocating memory anyway for these blocks. We have a zombie. We make one zombie, set some variables related to it, and okay, int numBlocks equals 2. Yeah. So this is the half-baked part, because I'm actually using this part where it's a little hard-coded, and so I was trying to make it a little more dynamic here, and I just copy-pasted something in, and I'm not even using it, I'm pretty sure. Just make sure this compiles just fine. Yeah, this is the same program. Right. And okay, so blocks here, yeah, like I said, just basically hard-coded. The only things where there's collision detection happening right now is R2 and R5. So R2 is, but I don't know. Sorry, I'm not sure exactly what's going on. All right, so now here's the line VAO. And line vertices 0, to 0, 1. So I kind of made a mistake, I think, when I first was implementing this. I thought I could get away with just using X and Y coordinates only, but you basically can't. I think that you can't because, yeah, because OpenGL uses X, Y, and Z just by the way OpenGL works. So I switched to doing it this way, and so this is, imagine, so our lines are just 2D, right? So here think 2D, here think 3D for these. So this is the point 0, 0, this is the point 0, 1, 0, 0, 1, 0. All the z values here are 0. So yeah, we created some basically raw data for these line vertices and so on. And this is all for the VAO, or sorry, for the lines. And so we've got a VAO, a VBO, vertex buffer object. This is sort of just standard procedure. And yeah, for drawing lines. One attribute pointer. Again, there's been videos on this kind of stuff before. Okay, so this stuff is not really doing anything. And well, ideally I should switch maybe to using quads instead of lines. You know, basically if I want it to be 1 pixel in width, just make quads that are 1 pixel in width. Thing is that, so I was very happy about how I implemented this line stuff, and then when I tried to adjust the width, I found on Stack Overflow that this adjusting the width is not guaranteed to be supported on all GPUs, and this stuff that kind of maybe is supposed to work. Maybe this is supposed to make it the lines 7 pixels wide, but it's not. The lines are 1 pixel wide, and so it seems like on my GPU, it's not considering this. You're just not able to set the line width. So it makes sense then that I would switch to using quads. The implementation will be, in my opinion, a little more complicated, but I will be able to get rid of all of this, though. So yeah, trade-offs. Okay, so anyway, I think like if you're watching my OpenGL tutorial series, I think I'll add like there's this directory called collections, and this is the kind of thing that I would put in collections is if anybody wants to do lines, not as quads, but just lines. Oh, here we go. And actually in the series, I skipped straight to quads. I didn't even do triangles, so I'll add one collection that is just a triangle. So it's stuff that's maybe not going to be in the, and I'll probably make a video about lines, and talk, once that's in the collections and all that. And so the collections are sort of just for little things that aren't really part of the main tutorial series. Yeah. Again, yeah, so this is not really doing anything. And this was another attempt to fix the width. But anyway. All right. Here's our while loop, our game loop, if you will. Setting time here. Kind of talked about delta time. It's the difference, basically the time that it took to render the last frame. Well, it's current time minus last frame, so to be precise. GLFW get window size. So this is, so I recorded these videos on this and then I forgot to upload it for a while, and I uploaded it recently. I think it's my most recent videos on OpenGL. And that is just basically, let's check this out. So there we go. Before, if I adjusted the size of the window, it was sort of panning. So it's cool. It makes the cursor disappear. It's kind of confusing. But anyway, it would pan around. It would not stay centered. See how it stays centered? So in order to keep it centered like that, I needed this GL viewport, which I think you're just supposed to put in anyway. It's like sort of the basics. It's supposed to be there. But it fixed the problem. And so by getting the window size, then it will get it within the while loop, and then it will change the viewport if the window size is changing. And I'm just thinking now about these I said earlier are kind of like duplicates, but the difference is that these are changing all the time, whereas the other ones were, they are meant to be kind of the initial size of the window if we don't do full screen. So those are kind of different. I could, I guess, name the other ones better as sort of initial desired window size or something like that. All right, so we get into movement, and I'll just make this full screen. Movement and collision detection stuff. All right, so if keys, we'll see how this works later at the bottom. But basically, if I move right, here's if I move left, up, down, and you've got these ORs. And so I can use WASD instead of up, down, left, right. I can use either one. And so if right, then the X value increases. If left, X value decreases. Up, the Y value increases. Down, Y value decreases. Did I say decreases here? Increases and decreases. All right, and then after we process this movement, then we do a little collision detection. So for all of the blocks, here's the number of blocks. we need to check the collision, and so we pass in the address to the rect R1, that's the player, and we pass in the blocks. So for each block, it's getting passed in, and so it has if. So let's look at this check collision function. Here's the function. This is basically copy pasted from, if you look how to do 2D collision of rectangles online, generally the first result is Mozilla Firefox, I guess, has posted about this, so it's sort of just copy pasted from there. I guess there'll probably be videos on collision detection, and there's already lots of videos out there. There's lots of information online, but yeah, if all these things are true, these 4 different lines are true, then there was a collision, and we return 1, which means collision. Otherwise, return 0, which means no collision. Okay. And I screwed that up. Check collision. All right. So if there was a collision, right, then it will let's see, it will set the x value of the player to being whatever it needs to be, which is the x value of this, the x value of the block minus the width of the player. Okay. Because you can think of, the x and y values are, well, the x values for a block or rectangle is counted from the left side. For y, I forget. It gets a little complicated when you think about the y-axis. Yes, similar kind of stuff. I don't want to bore you with kind of like same explanation. This time it's plus the width of the block, right? This is if they move left and they bump into a block, then it will set them, their x value will get set to the the x value of the block plus the block's width. Y, similar stuff for both of these, okay? You can pause the video and look if you want. So if player can jump bool and keys space, so I'm jumping with spacebar, so if I hit the spacebar and the player can jump, then this is a jump. So I could comment that, but honestly, it's pretty obvious to me, so. Yeah, let's just do it. Player jump. If I come back in 10 years or something, I'll need to know what this is about. Anyway, player upward velocity, so we add to the velocity. Later, the velocity gets changed again, I'm sure. We'll see where that happens. And it's set to false because we jumped this boolean. And, okay, gravity. So player downward velocity plus equals delta time times 0.03. Later, when the player hits the ground, we reset this to 0, but as they're floating in the air, so they have a downward velocity and an upward velocity. There's different ways of implementing this, of course, but basically gravity is acceleration. So acceleration is where your velocity or your speed increases with time by a constant value. So this is basically just a constant. I just fine-tune this for however fast I want the player to fall back down to the ground. Yeah. So let's talk about this physics real quick. I'll just, because I said it, but I want to actually explain. Gravity is, so you're going to have force equals mass times acceleration. So, okay, actually, that's not even related. I'm not gonna go into the physics, but it's when you're, you're accelerating by the constant of gravity, right? So it should be 9.8 meters per second or whatever. So each time that, for some amount of time, that's why we're using delta time, some fixed amount of time, we are going to increase the speed or velocity by a fixed amount. So it's just by a constant. It could have been 9.8, but just based on the world, because we're not actually using meters in the game, you know, how that would pan out, it would have been way too fast. So you just try something and then you change it to see what works. All that explanation is to say that it's not something weird like some time squared or something, you know. It's multiplied by a constant, that's all. So set player y velocity. So this is not the velocity, this is the player upward position. And it's going to be plus equals, so it's similar to the r1.y. But anyway, this is just counting, though, it's just counting from the jump. So because of the y, I didn't choose the best names of the variables here. Upward velocity minus downward velocity. So this is just from the jump, how much above the ground should the player be, right? Upward velocity minus downward velocity. And so if player upward position is less than 0, so this is if they hit the ground. Basically, it starts out at some small number. Well, over time, where was it? Let's see here. Where's downward velocity getting set? All right, this is the downward velocity. So we start with an initial upward velocity, pretty small. It does feel weird that these numbers are bigger, but this is getting multiplied, and this is additive. And the delta time is a small number. It tends to be about the amount of time between each frame. And so it's a very small number. So this gravity that's pulling the player down each frame ends up being a quite small number. This upward velocity is just becomes 0.01 just at the moment of the jump, and after that it does not change until the player hits the ground. It gets reset to 0. Everything gets reset to 0 when the player hits the ground. This is, should comment it, player hits ground after a jump. So where were we? Right, so you initialize basically with a upward velocity of 0.01, and then each frame you subtract a little bit. Well, actually, this stays the same, but this will increase by a little bit each frame. And so the upward position, each frame changes by basically the total vertical velocity. I think this is very confusing to sort of listen to this explanation. If it comes to making a video on this kind of gravity implementation, I'll really think about how to explain it nicely. Okay, GL clear color. Okay, this is not really, doesn't really matter right now, but yeah, clearing it out, clearing out the main buffer, frame buffer. This is getting calculated here. Well, yeah, this should be in the while loop, because if we adjust the size of the window, it will change. Mouse X, mouse Y. I could have just kept this, I guess. But I turned it up, switched it upside down, because normally windows for the this is just computing in general. It doesn't matter which platform. The x, y equals 0 is considered at the top left for a window. And I prefer to, when I'm making a game or something, I prefer to think of 0, 0 to be at the bottom left, like it was in math class. So this is just flipping the y-axis here. Let's see, r3.x equals all this stuff. Right, so r3 is the tower. Okay, that's what this stuff is. Just determining some x and y values for r3. And let's see here. So then we bind the vertex array object. So we're going to do some rendering here now. So you see this common pattern here. Use program, set some stuff, then draw. Use program, set some stuff, draw, so on. Also binding textures each time. So here we have a textured quad shader. And this is for using the background. I could just make it like the others and change the order here. The order there doesn't matter. Setting texture. So you kind of only deal with one texture at a time. And so I'm setting it to the background texture. I'm setting the shader to the textured quad shader. It's what it sounds like. It's rendering a texture. This trans is for translation. It's going to set the position. Here's scale. Scale is generally what's going to be kind of the, should be the width and size. Sorry, the width and height of the thing. So if we go to textured quad, let's see here. Yeah, it's getting used. Scale is getting used. Okay. Oh yeah, it's the background. That's why it's so big. It's not the OpenGL thing is it's not a 1x1 cube. It's a 2x2x2. It goes from -1 to +1 in the x, y, and z directions. This is what actually draws it. So I could be using some function to draw these. That would probably be a good idea. I'm not doing that right now for whatever reason. So now we have the the tower, and it was R2, not R3. Whatever. Forget what R3 is. I should use better names. Okay. Yeah. It sets a color. It doesn't need to do that. No, it doesn't need to do that. Draws it. All right. I switched this draw function to taking a shader as an input. That's right. Cool. All right. Zombie texture, walking zombie shader. So it's a pretty primitive little shader because there is the walking animation. So if we look at here's the sprite sheet. So I can't really zoom in here to my knowledge. If I can, I don't know how. But there it is. So it's using the sprite sheet. So you have the little animation. Let's just check. Again, see it's animated. It's switching between two of those sprites. There'll be separate videos on that. So, and actually I need to make it a little more feature rich, I think. Okay, so that's zombie, and I'm just changing this is really, we say in Japanese tekito, like going with the flow here, just popping it right there in the while loop, Then shadow, right, there's a little shadow, as you may have noticed, when the player jumps. And it gets squeezed a little bit. I really like that. So we have still using the textured quad shader. There's actually a texture let's see, look at the shadow texture. It's this. Amazing, isn't it? And so it has, its color is actually, was it important for the opacity? I forget if I'm using the opacity there. But hold on, sorry. Scale modifier. So this scale modifier is getting used when adjusting the scale, because that will affect the size of the thing. So there was some adjustment. I forget exactly what it was. You know, I did some math and just tested it incrementally, just made a bunch of incremental changes. And that's what I arrived at. So yeah, this is about centering it, basically. All right, sprite shader, hero texture. So the hero, does he have any animation? I don't think the hero does. So I almost don't know. Oh, there's no animation, but it is choosing part of the sprite sheet. So textured quad shader. Right, this is that. No, sorry. Cursor, that's the cursor. Now, where is its position getting set? Somewhere else, obviously. You know what? I think it's in the callback function for the mouse. We'll see later. Maybe that's, I can't remember if that's a bad place to put it. Draw rect textured quad shader. Okay. Yeah. GL use program colored quad shader. This is not. Oh yeah, this is for the bullets. And accepted X accepted. Oh, this was for testing. But it's here actually. So I'll just pop this in here. Make sure that this compiles fine. So this part, I'm not going to talk about too long. This was just, before I drew the bullets, I wanted to sort of coat the entire screen in a bunch of little boxes, little rectangles, quads. And so I basically a big array of them. And the way that this little game world is, it's designed to be 230 by 230 in the X direction, 135 in the height in terms of pixels. 230 by 135 pixels is sort of, oops, the game world here. Do you see how it's sort of pixelated? You see that? The background, and anyway, that's the idea. So I wanted to cover it in that many blocks. So 230 by 135 is this number. It should actually be this number. But to verify, because you see the whole thing covered in these squares, so it just looks like one quad being drawn, although it's actually this many. So I make it a little smaller just to verify that the corner is not being drawn. Let's just see what happens if I uncomment here. And yeah, let's just see if that actually still works. No. But this appeared, and it got a lot slower. That little square. That's the accepted X and Y. Accepted, if accepted. See if that does it now. Yeah, so it's covering the whole screen, but again, and it's got some opacity so you can see through it a bit. This part up here is that last 50 or so that are not being rendered, just so I can make sure that it's really doing what I think it's doing. It's not just one big quad, it's really a bunch of squares. So I did that before I was creating the bullets for some reason. I don't even know why. Just make sure that they sort of fit into the worlds with the correct size, I guess. So actually, Yeah, I think it was kind of about getting these dimensions, like this math here, kind of correct, because there's some math here. It's really simple though, so I don't know. There's a warm-up, I guess. And I just left it because it might come in handy later at some point. So if bullet, switch bool. So this is when I click the mouse and it shoots a bullet, as you saw before. So we increase the number of bullets. We reallocate the memory for these bullets. So number of bullets times the size of a bullet. And that happens to the bullets array, I guess. It's an array of... I guess it's an array of bullet structs, but I just think of it as a pointer, right? Somebody let me know what the correct nomenclature is. All right, num bullets -1, because if num bullets equals 1, then it means you only allocated memory for bullets 0. So that explains why there's -1 in here. It's getting late, I can't even think of how to explain it, but that's the explanation. Let's see, distance shot equals 0.07. So this is really just an initialization of a bullet. We give it a little distance to start so that it doesn't start on top of the player. And I just fine-tuned that through incrementally testing it out. And bullet switch bool equals false. So switches it off. So it happens just once per click is the idea. So once it gets initialized, it initializes one bullet and then it switches that off to make sure it happens also only in just one frame. For int I, so for the number of bullets, this is going to happen, and so this is the rendering of each bullet. And there's no deletion of the bullets going on, so that's something I should do, is that once the bullets fall off the screen, they get destroyed. This is obviously commented out, but what was it about? I don't know, but I think I left it there in case I want to use this colored quad shader. I don't think I'm using those. I'm using them for the bullet. I honestly don't know. Maybe I can just get rid of this, but might come in handy at some point. So is drawings, so this is for that drawing of the rectangle, the selection rectangle. Got some adjustments. Again, that was about, I explained that before. So yeah, it's because my cursor isn't really a mouse. It's that weird image, right? The gauntlet. Dwarven gauntlet. I found those on the free game assets website. So we bind our line VAO. We set our shader program to what it needs to be. That shader, I'll go over the VS and the FS when I make the video for that. Line shader color. Yep, sets it to red. Opacity 1.0. Line start point uses the adjusted mouse click X and adjusted mouse click Y. Scale. So these go into the shader. I'll just flash the shader on the VS and FS on the screen, and you can if you're interested, pause the video and look at them. So here's the VS, and here's the FS. It's really simple, because it's just rendering red for each fragment, right? This one is a little more complicated. It needs the line start point. Okay. Cool beans, man. All right. Oh yeah, this is actually kind of big. Sorry that looks like that. I guess I could turn on the dreaded, hold on. Menu, toggle menu, and word wrapping. Wait. Yeah. Where were we? Scale, okay. Resolution, okay. Actually, these ones kind of long. Why does it need scale? You know what? that's what determines the size of the box, basically. Okay. Yeah. And resolution. Okay, it's pretty sure that's not being used at all because it's just a 1 pixel line at this point. Isn't this happening twice here? It's getting drawn in 2 parts. It's a little complicated. Let's just check that this is still working fine because I made that change. No, it's not. All right. Whatever. I'll leave it there. I think it's not really necessary, but it is getting used here. So, oh right, for the start point. Okay, that makes sense. Yeah. Drawing 2 here, 2 here, so that's 4 lines. Cool beans. Only if we're drawing it. Okay. Draw window shader. I mentioned it's the full thing. I already talked about that. And we got a little function. We'll see that later. Read pixels. So this is for if I'm writing. So if writing we have down here, I could make it, should actually change this so that it's up here. Reformat this a bit. And okay, so this one kind of shows you left top width height here. Using RGBA, A is that opacity, alpha. Yeah. You can look up the docs if you want more info on this, but we're passing the pixel data into this little guy. Originally I was using this, just testing it to a JPG, but then it would always write, each frame it would write to the same file. Which, by the way, if you turn this on, it slows the program down big time to where it takes maybe 1/3 of a second per frame. So you're looking at maybe 3 frames per second or so. Not even that. It's like 2 frames a second. Again, that is bottlenecked by not by this, but by the actual writing. This is going to bottleneck it because it's turning from electricity that's in your RAM and your CPU. It's switching from that to physical storage of data in your disk. So that is going to be a huge bottleneck. Yeah. Unless whatever your graphics you're doing, it was so crazy that the graphics were actually putting you down to 1 or 2 frames a second or something. All right, so this part is all about getting the path for writing the JPG file. So we got a path, we got a file extension, we got a directory that I chose. We've got just some string concatenation stuff going on here in C. Total princess batch gets added, so it ends up with a bunch of numbers. I'll just show you game 4. And so you end up with all these little numbers. And that is, again, used together with this FFmpeg thing to render the madness. I did this flip vertically on right, and things were printing out upside down. So, yeah, nice little feature of the image libraries. Some have these kinds of features, some maybe don't. And we write it. We got a path. Looks like a width, a height, number of channels because we have opacity, so it's RGBA. Passing the frame data. 100, I believe, is quality of the JPEG, setting it for 100%, I believe. JPEGs, you can have different levels of quality. We increment total princess batch. Yeah, and that actually ought to be, really should be here. Swap buffers, that's how we render. I've talked about that before. Pull events, that's how we get our input and our output. And I think it's optional. I want to test what actually happens. Maybe I'll test even on different systems, but yeah, we're cleaning up. We're being good little boys and girls. We're cleaning up the memory by deleting the shader programs. So my concern is, yeah, I think the operating system will clean that up. But there's a possibility in my head that maybe it won't, and so it will have a memory leak, which means it's going to be taking up RAM until the user restarts the computer. Anyway, then this is how you stop glfw, return 0. Okay, that's it for the main function, and now we'll go into these. We're almost done here. Got some functions. Draw rect takes a rectangle and a shader. It uses the shader. It sets the translation and scale information, and then it draws the guy. I was using colors before, like I said, but I'm not using it this time. Draw window shader. I talked about what I mean by window shader. And we use the width and height for the resolution part of the shader. So you can kind of see what that is. This stuff is irrelevant, but again, well, I might switch back to, I might use this particular shader at some point. So then this kind of, there's one that renders text, kind of interesting. Interesting for a shader to actually render text like that, like in the fragment shader, basically is where it's getting figured out using, yeah, I don't know. Anyway, I forget if it uses a UBO. Yeah, I think it uses a UBO, a uniform buffer object, which is a way to transfer more data to the shader program. Okay. Yeah. Check collision we talked about. So we just got our input output and then the setting up the VAO. So keys, I'm not going to really talk about this. It's kind of just boring to talk about. Got keys, you know, we can push them and we can check this array, blah, blah, blah. It's kind of a GLFW specific kind of stuff. This might be from the docs. I'm using escape so you can, if you press escape, it closes. Mouse. Sets these guys. First mouse, not using, but okay, it's there. X offset, X offset, Y offset. This is not being used, is it? I mean, they're being declared here, so. Don't know what this is for. There for. CD dot CD code, CD dot CD code. Leave a like if you, what am I doing? CD dot slash run. Leave a like if you know what I'm referencing. All right, something weird happened, didn't it? Maybe I screwed it up somewhere else though. Time is not going by anymore. I'll figure it out later after the video. Must have screwed something up. Mouse buttons. Yeah. This is getting too long and I'm getting tired. I think you guys get the idea. Not being used, the scroll. And the VAO I'm just not going to talk about because watch my past videos. Same with the texture handle. And that's going to be it for this video. I'll probably make another one for the talking about the fragment shader for this crazy graphic that you see. And thank you for watching, and yes, stay tuned if you're interested. Please do subscribe if you would like to do so. If you would also like to hit the like button, that would be super, super duper cool, you know? Oh man, that sounds so lame. Oh my god. Alright. That's it. Peace out. Thank you. Bye-bye.